Yo, yo, yo. Okay, so we'll be doing Kirchhoff's current law. And what it is essentially the current going into the junction, right? Is the same as the current going out. What you put in is the same as what you get out. And therefore, the total current should add up to zero. You shouldn't be gaining or more. You shouldn't be gaining or losing current in a system, really. So, in my previous video, we went over the precise definition of a nodal junction. It's basically the point that connects multiple elements together. So, with that out of the way, let's say we have this wire, right? And the junction is located right there. That's the green dot. And we have current going through the junction. We have 4 amps going into the junction. And we have 10 amps going away from the junction. Now, the fact that currents going in and out of junction is a big deal because that dictates the direction of current relative to the junction. And we're going to identify these as current 1 for 10 amps and current 2 for 4 amps. And because the direction of the current matters, which one's negative? If you were to say the current one is negative, you would be correct. As for 4 amps, because it's going into the junction, it's, well, positive. It's positive current. But there's one current that hasn't been identified yet. I3. What is the magnitude and direction of that current? And it turns out all we have to do is go back to our fundamentals. Now, numerically, right? If I3 is greater than 0, that means it's going into the junction. If it's less than 0, it's going out of the junction. Also, the sum of the current in the system should also add up to 0. What that means is I1 plus I2 plus I3 equals 0. And we only really need to solve for I3. So negative 10 plus 4 is negative 6. We're at 6 both sides. And because I3 is greater than 0, it's going into the junction. Let's see here. So I don't know why that's there. But yeah, this is what we have. And the circle is to indicate that because it's greater than 0, it has to go into the junction. Otherwise, it had to be less than 0 for it to go out of the junction. Now, let's do another example where we have this formation right here, and the junction is there. Now, we have current 1 being 14 amps, and it's going into the junction. And we also have current 2 going away from the junction at negative 10 amps. I'm also going to identify current 3 as an unknown variable. You will notice that it's very similar to the prior example. It's just that it looks different. And even though it looks different, the process is still the same. For example, the summation of current equals 0. So therefore, the sums of I1, 2, and 3 should add up to 0. And since I3 is unknown, we just apply direct substitution. So positive 10, negative 10, that's positive 4. So therefore, I3 should be negative 4. And because I3 is less than 0, right? Should it be going into the junction or out of the junction? Should be going out of the junction. And if you want to confirm that the answer is right, or at least double check, let's add up the current going into the junction. So the current going into the junction is positive 4 amps, yes? What's the magnitude of the current going out of the junction? So negative 4, negative 10, that gives out a sum of negative 14. So therefore, in terms of double checking, we are correct. Now, let's say we have this formation right here, and we have the following current, where we have I1 as 9 amps, I2 as 10 amps, I3 as 4 amps, and I4 is unknown. Excuse me. So, I left out the positive and negative notation. That's not to say they don't matter. I just want you to actually solve for them. So, I2 and 3. Which one's negative? Turns out that I1 is negative, and as for which current is going into the junction, does that make them positive? Yes, yes it does. And once again, by going back to the fundamental rule that the summation of currents equals 0, it's all a matter of direct substitution, since I4 is the only unknown variable. So let's see here. 10 and 14, that is 14 amps. 14 amps minus 9, that should be 5 amps. So therefore I4 is negative 5 amps. And hopefully by now you realize that because it's negative, what direction is it going? Relative to the junction. It should be going away from the junction at negative 5 amps. Now, let's do another example. Let's say we have this formation right here. And let's also identify one current that's going into the junction and another current going into the junction as well. We also have a third current going away from the junction, and now we have two unknown currents. Oh no. However, this would actually be really hard to do with this amount of information given. So we're going to have I4 is equal to 2 times I5. And this should make this problem much more feasible. So we know that some occurrence has to be 0, and we know I2, 3, and 4 technically, and that's fine. So let's see here. We know I1 is positive because it's going into the current. The same goes for I2. I3 is negative because it's going away from the junction. And you'll notice something. I4, where is that? Well, we established that I4 is equal to 2 times I5. So we can actually switch out I4 with 2 times I5. And as a result, we only have one unknown variable, which is I5. So what do you get as a result? Well, you get 29 amps plus 2 I5 plus another I5. And you just add like terms in terms of I5s and just solve for I3. Oh, sorry, you solve for I5. So you just subtract 29 divided by 3. And since it's a negative value, the current of I5 should be facing away from the current, away from the junction. Now, what about I4? There are two options to solve for I4. We either do what we did again and solve for I4, or we grab the purple expression and solve for I4 with I5 already identified. So what's it going to be, guys? For me, I'll go with the latter, where it's just 2 times the fraction, which that will produce the value of I4. And yes, because it's negative, it's going away from the junction. And again, if you want to double check your work, especially with fractional outputs, you can. The current going in is positive 37 amps, and the current going out is also negative 37 amps. You can do the math to check and confirm in the comment section. But fundamentally, this is how you find current, or you find current using Kirchhoff's current law. And I hope this helps.